Two magnitude 6 earthquakes just struck the same dot on the seafloor between Australia and Antarctica, 11 minutes apart, at identical coordinates, at the same depth. The pair was so statistically unusual that the immediate question inside the seismology community was whether the catalog had glitched. It had not. They were the only magnitude 6 or larger pair in the entire global earthquake catalog this week. By the time this video ends, you will know exactly what happened down there, why the viral explanation circulating online is wrong, and what the real science says. At 51 minutes past 2 o'clock yesterday afternoon, Coordinated Universal Time, the United States Geological Survey catalog logged a magnitude 6.0 earthquake on the seafloor between Australia and Antarctica. 10 minutes and 6 seconds later, the catalog logged a second magnitude 6.0 earthquake. Same magnitude, same coordinates to the 100th of a degree, same depth, two identical earthquakes, 11 minutes apart, at essentially the same dot on the map of the seafloor. The pair was so statistically unusual that the immediate question inside the seismology community was whether the catalog had logged a duplicate entry by mistake. It had not. Both events were confirmed by the European Mediterranean Seismological Center, with matching coordinates, matching depths, and matching magnitudes. They were two real, independent ruptures of the seafloor, recorded by the Global Seismic Network from 1,000 kilometers away, and they happened in a way that does not fit any of the standard earthquake patterns. Most earthquake pairs follow Bath's law, one of the most consistent empirical results in seismology. The largest aftershock is typically about 1 magnitude unit smaller than the main shock. If a magnitude 7 hits, the largest aftershock is usually around 6. If a magnitude 6 hits, the largest aftershock is usually around 5. The pattern is so reliable that pairs of equal magnitude events stand out immediately in the catalog. The pair yesterday violates Bath's law. Both events were the same magnitude, not 1 unit smaller, not half a unit smaller. The same, what you are left with is the textbook seismological definition of a doublet. Two earthquakes of comparable magnitude occurring within a short time interval at essentially the same location. Doublets exist in the global catalog. They have been documented across a wide range of tectonic settings, but they are statistically rare, and the conditions that produce them are different from the conditions that produce a typical aftershock sequence. The doublet yesterday was the only magnitude 6 or larger pair in the entire 7-day global earthquake catalog. The only one anywhere on the planet. In a full week of data, that is what makes this event worth a closer look. Not the magnitude. Magnitude 6 earthquakes happen on this kind of plate boundary every several months as a matter of routine. The unusual feature is the pattern. Two ruptures of identical size, on adjacent fault patches, separated by only 11 minutes. The combination is rare enough that scientists are paying attention, and rare enough that a viral framing has already attached itself to the news, trying to explain what happened. The viral explanation is wrong. The actual explanation is interesting on its own. Here is what the data shows. The location is one of the most remote places on the planet. 50 degrees south latitude, 139 degrees east longitude. The closest land is the southwest coast of Tasmania, Australia, about 990 kilometers north-northeast of the epicenter. The closest population center is Hobart, the capital of Tasmania. The closest scientific research station is the Australian Antarctic Division Base on Macquarie Island, several hundred kilometers east. The Antarctic coastline itself is roughly 2,000 kilometers to the south. Between these distant outposts, there is just ocean. Cold, deep ocean. Some of the most isolated water on Earth. The plate boundary running through this stretch of seafloor is called the Southeast Indian Ridge. It marks the boundary between two of the major tectonic plates that make up the planet's surface. The Australian plate to the north, carrying the continent of Australia and a large piece of the Indian Ocean. The Antarctic plate to the south, carrying the continent of Antarctica and a wide ring of seafloor surrounding it. The two plates are moving apart at an intermediate rate of about 65 to 75 millimeters a year, about 3 inches per year. Slow on a human timescale, substantial on a geological timescale. Sustained over 30 million years, since the Oligocene epoch, the spreading at this ridge has built up about 2,100 kilometers of new ocean crust between the two continents. The ridge is not a straight line. It is offset, segment by segment, by transform faults, horizontal slip faults, that connect adjacent stretches of the spreading axis. The ridge segments are where new crust is being created. The transform faults are where two blocks of seafloor on opposite sides of an offset slide past each other in a strike-slip motion. The transform faults are also where most of the earthquakes happen. The ridge axis itself, where magma is rising and crust is forming, produces relatively few earthquakes because the deformation there is taken up by molten rock. The transform faults are brittle, frictional structures that store strain over decades and centuries and release it in earthquakes. The doublet yesterday was on one of these transform faults. The location, the depth, the geometry, and the strike-slip mechanism all point in that direction. The seafloor was not splitting apart vertically yesterday. Two blocks of crust on opposite sides of a transform fault were sliding horizontally past each other. One block slid first, releasing a magnitude 6 earthquake. 11 minutes later, the next patch over slid, releasing a second magnitude 6. That is the picture. There is one important thing to know about how this kind of fault produces earthquakes, because it has direct consequences for what kind of damage these events can cause. Strike-slip motion on a transform fault moves the seafloor sideways. Not up, not down, sideways. The water column above the fault does not lurch upward, because nothing under it lurched upward. There is no large tsunami. The strike-slip mechanism is the reason no tsunami warning was issued yesterday, despite both events being magnitude 6. The same physics applies to every transform fault earthquake on this kind of plate boundary. The Pacific Tsunami Warning Center, the National Tsunami Warning Center, and the regional centers all use automated thresholds that evaluate the focal mechanism of every earthquake. Strike-slip events on transform faults do not displace water vertically, and the warning systems therefore do not issue alerts. There is no suppression. There is no political concealment. The physics determined the absence of a warning, and the physics was unambiguous. The deeper question is what brought two adjacent fault patches to failure at almost the same time. The most defensible scientific explanation involves stress transfer between adjacent patches on a transform fault. When an earthquake ruptures one patch of crust, it changes the stress field in the surrounding crust. Some directions of stress increase, some decrease. Patches that were already close to failure can be pushed over the edge by this stress change. This is one of the most studied phenomena in earthquake physics, and it has a name. It is called Coulomb stress transfer. There are two flavors of stress transfer to know about. Dynamic triggering happens when the seismic waves from a first earthquake briefly stress a neighboring fault as they pass through. Dynamic triggering operates on timescales of seconds to minutes, because the waves travel fast and decay quickly. Static triggering happens because the first rupture permanently changes the stress field around it. Static triggering operates on timescales of hours to years. The 11-minute gap between yesterday's two events sits in the overlap zone between these two regimes. It is on the longer end of pure dynamic triggering. It is on the shorter end of pure static triggering. Either mechanism could plausibly explain the pair. Probably both contributed. The most likely picture is that the second fault patch was already extremely close to its individual failure threshold when the first one ruptured, and that the combination of dynamic shaking and the permanent static stress change from the first event was enough to push the second over the edge within 11 minutes, instead of within months or years. The identical magnitudes of the two events suggest something specific about the local fault geometry. They suggest that the local section of the transform fault is segmented into approximately equal-sized blocks separated by smaller obstacles or stepovers. Each block stores roughly the same amount of strain. Each block releases roughly the same amount of seismic energy when it ruptures. The doublet is then a glimpse into the segmentation of the local fault system. Two adjacent blocks of similar size and similar stress state ruptured in close succession because they were both ready to go, and the first one took the second with it. This is the standard explanation. Not exotic, not mysterious in any deep sense. The mechanism is well understood. The mathematics of how a rupture changes the surrounding stress field has been worked out in detail. The empirical record of doublets and triplets at various scales has been built up over decades. What is unusual about yesterday is not the mechanism. It is the timing. 11 minutes is a short interval, even for stress transfer pairs. Most documented pairs are separated by hours to weeks. Pairs separated by minutes imply that the second patch was very close to failure indeed, possibly within a few percent of its threshold, and that the first rupture's static effect was just enough to push it the rest of the way. The 11-minute gap is a measure of how tightly the local fault system was loaded. The reason this video is not about damage, evacuation orders, or rescue operations comes down to two facts about the doublet. The first fact is the location. There are no cities anywhere near the epicenter. There are no fishing fleets close enough to feel anything. There are no buildings on the seafloor. The closest land is nearly 1,000 kilometers away, and the closest population center is small. The strike-slip motion of the two events transmitted seismic waves through the deep earth and reached the global seismic network as faint pressure signals, but it did not transmit any meaningful ground motion to anywhere people live. The second fact is the mechanism. As explained, strike-slip ruptures on transform faults do not displace the seafloor vertically. They displace it sideways. This means no tsunami forms. The Pacific Tsunami Warning Center did not issue an alert because the warning system, looking at the focal mechanism of both events, determined that no large wave would propagate. The same physics that produced the doublet also guaranteed that the doublet would not threaten anyone. The Southeast Indian Ridge, like every divergent plate boundary with transform fault offsets, is essentially incapable of producing the kind of vertical seafloor disturbance that generates major tsunamis. The earthquakes here can be substantial in magnitude. The Macquarie Ridge, a few hundred kilometers east of yesterday's epicenter, produced a magnitude 8.2 strike-slip earthquake in 1989, one of the largest strike-slip events in the seismic record. That event still did not produce a major tsunami, for the same mechanical reason. Sideways motion of the seafloor does not push the water column up, so the doublet yesterday released a substantial amount of seismic energy. Two magnitude 6 events, with a combined seismic moment equivalent to a single magnitude 6.2, about 1/32nd the energy of a magnitude 7, about 1/1000th the energy of a magnitude 8. Substantial in absolute terms, important in seismological terms, but released in a place where no one was exposed and in a way that did not threaten anyone even if they had been. The mechanism that produced the doublet is the same mechanism that contained it. In the hours after the doublet was cataloged, a viral framing started circulating on social media. The framing claims that earthquakes like yesterday's are evidence that the Earth itself is expanding, that the planet is slowly growing in radius, that if you compress the modern Earth down to a smaller diameter, all of its landmasses would close together to enclose the surface without leftover ocean space. That Pangea, as we currently understand it, never existed in the form most textbooks describe. That Earth used to be smaller, that it is getting bigger, and that hundreds of millions of years from now, it will be the size of Jupiter or Saturn, and will have transformed into a gas giant. This is the expanding Earth hypothesis. It is not new. Versions of it have been around for nearly a century. The earliest documented advocate was a German engineer named Ott Christoph Hilgenberg, who in 1933 published a book called Vom wachsenden Erdball, about the growing Earth, presenting papier-mâché globes about 60% of the diameter of the modern Earth on which all present day. Continental crust closes up to cover the entire surface with no oceans. The hypothesis was substantially expanded in 1956 by the Australian geologist Samuel Warren Carey of the University of Tasmania, who developed his own version after a major symposium he hosted on continental drift, and who published a book called The Expanding Earth in 1976. Carey was a serious scientist who had been one of the earlier advocates of continental drift itself. His argument was that the rate at which new crust was being created at mid-ocean ridges, as far as could be measured in the 1950s, was not balanced by any equivalent rate of crust destruction at subduction zones. If spreading was outpacing consumption, the only way to conserve the geometry was for the planet to grow. That was a reasonable argument in 1956. It is not a reasonable argument in 2026. The data Carey was missing has been accumulating for 7 decades, and the question has been settled. The expanding Earth hypothesis fails on 6 independent lines of evidence. Any one of them is sufficient to refute the hypothesis. Together, they leave no room for it to survive. First, direct measurement of Earth's radius. In 2011, a research team led by Xiaoping Wu of NASA's Jet Propulsion Laboratory measured the rate of change of Earth's average radius using satellite laser ranging, very long baseline interferometry, the global positioning system, and gravity data from the GRACE satellites. The team's result was that Earth's radius is changing by approximately 1/10 of a millimeter per year, about the thickness of a human hair. That rate is statistically indistinguishable from zero. Within current measurement precision, Earth is not growing. The radius is stable. Second, direct observation of subduction. Carey's original objection was that subduction could not balance spreading. That objection has been tested. The convergence rates at the Aleutian, Japan, Mariana, Tonga, Kermadec, and Peru-Chile trenches have been measured directly by GPS and by paleomagnetic analysis of seafloor age. The Pacific Plate is being consumed beneath Japan at about 8 centimeters a year. The Nazca Plate is being consumed under South America at 6 to 10 centimeters a year. When you add up all the global subduction rates, they match the global mid-ocean ridge spreading rates within measurement uncertainty. Crust is being created at ridges. Crust is being destroyed at trenches. The net change in surface area is zero. This is exactly the balance Carey said could not exist. Third, paleomagnetism. The orientation of magnetic minerals locked into ancient rocks records the magnetic latitude where those rocks formed. The paleomagnetic record across the past several 100 million years is consistent with an Earth of roughly its current radius. If the planet had been substantially smaller in the past, the geometry would show systematic distortions that have not been observed. Fourth, the energy budget. For Earth to grow from 60% of its current diameter to its current size since the Mesozoic, the planet would need to add about 1,000 quintillion kilograms of mass, roughly 300 million tons per second, continuously, for the entire interval. The measured rate of meteoritic accretion onto Earth is about 40,000 tons per year, total. That is 15 orders of magnitude too small to account for the proposed expansion. There is no other observed source of new matter. Fifth, rotational dynamics. A growing planet would slow its rotation as its moment of inertia increased. Earth's rotation is slowing, very slightly, but the entire observed slowdown is accounted for by tidal friction with the moon. There is no extra slowing that an expanding Earth would require. Sixth, the continental fit. The visual demonstration that continents fit together on a smaller globe is striking, but it is also a coincidence of geometric closure. Alfred Wegener in 1912 showed that the continents also fit together on a normal-sized Earth once you reconstruct the supercontinent Pangaea correctly. The Panthalassa Ocean covered the other side of the planet because Pangaea was a real supercontinent, occupying only a fraction of the surface. The Wegener reconstruction explains the continental fit perfectly well without requiring the planet to change size. Today's doublet is offered by the viral framing as evidence the Earth is expanding. Every one of the 6 lines of evidence applies. The doublet is one snapshot of seafloor spreading at the ridge. Spreading is real. But at the same time the doublet was being recorded, the Aleutian arc was consuming Pacific crust at 6 centimeters a year. Old crust being destroyed in the trench, new crust being created at the ridge, both happening simultaneously. The conservation equation is balancing in real time. The doublet is not evidence the Earth is growing. The doublet is one half of an equation whose other half is being satisfied at the exact same time on the other side of the world. The Southeast Indian Ridge does not exist in isolation. East of yesterday's doublet, the ridge approaches a complex feature called the Macquarie Triple Junction, where the Australian Plate, the Antarctic Plate, and the Pacific Plate all meet. East of the Triple Junction, the boundary continues as the Macquarie Ridge, which produces some of the largest strike-slip earthquakes in the global record. On the 23rd of May, 1989, the Macquarie Ridge produced a magnitude 8.2 earthquake. The rupture extended over 220 kilometers of fault in a bilateral pattern on a near-vertical fault plane. It reactivated a 175-kilometer section of fault that had been dormant since at least 1964. Anderson published a paper in Geophysical Research Letters in 1990 documenting the event. The Macquarie Ridge produced another major earthquake in 2004, a magnitude 8.1 strike-slip event, this time about 200 kilometers west of the plate boundary, in what was interpreted as an intraplate rupture inside the Australian plate rather than on the boundary itself. The 2004 Macquarie event happened 3 days before the December 26 Sumatra megathrust, a magnitude 9.1 to 9.3 earthquake that killed over 200,000 people. The temporal coincidence between the two events has been examined in the seismological literature, and no clear causal connection has been established. The two events were probably independent. What this larger picture tells you is that the Southern Ocean is geologically active. The plate boundary that includes the Southeast Indian Ridge and the Macquarie Ridge produces seismic activity at a level that, if it were happening on a populated coastline, would be one of the most studied regions on Earth. Because it is happening at sea in the cold ocean between Australia and Antarctica, it almost never makes headlines. Yesterday's doublet sits inside that larger story. It is a smaller event than the Great Macquarie Ridge ruptures of 1989 and 2004. It happened on the Southeast Indian Ridge proper, rather than on the transpressional Macquarie Ridge structure. But it is part of the same broad plate boundary system, and it reflects the same overall stress regime. The Australian plate is moving north at about 7 centimeters a year. That motion has to be accommodated somewhere. Yesterday, 11 minutes apart, 2 segments of a transform fault accommodated some of it. The 2 fault patches that ruptured yesterday have released their accumulated strain. They will not produce another magnitude 6 on the same patches for decades, at minimum. The local section of the transform fault is now in a relaxed state. There may be small adjustments. There may be smaller events as the system settles. But the next significant earthquake on this stretch of ridge will probably come from a different patch, one that was not part of yesterday's doublet, and it will probably not happen for some years to come. What seismologists will watch for over the coming weeks is whether any further moderate events appear on adjacent segments of the same transform fault or on the nearby ridge axis. If there are, they may indicate that the doublet was part of a longer stress release sequence that has not yet finished. If there are not, the doublet was a self-contained event and the local stress has been fully released. Either outcome is consistent with the standard physics. The viral framing will continue. The expanding Earth hypothesis has been refuted for 40 years, and it keeps coming back, because the visual demonstration of continents fitting on a smaller globe is memorable, and the format of social media rewards clean, simple, image-driven claims over careful, evidence-weighted ones. Each new earthquake on a mid-ocean ridge gets pulled into the same framing. Each time, the framing gets the right observation about spreading and ignores the equally well-measured observation about subduction, balancing it. The remedy is not to dismiss the framing. The remedy is to walk through the evidence, point by point, the way this video has just done. The doublet is real. The expansion claim is wrong. The actual science is on solid ground, and the data is publicly available for anyone who wants to check. We will be tracking this region as it develops. The Southeast Indian Ridge is one of the slowest clocked tectonic systems on the planet, but it is still ticking, and yesterday 2 ticks landed within 11 minutes of each other. That is the story.